objective is to explain you how to find out the root locus of the transfer function. We call this, whenever you want to find it, the root locus, you do it by this way. So how would you do this? Suppose I'm interested in finding a root locus of this part A, which is g of s, which is 400 divided by s squared plus 12s plus 400. So there are 10 to 11 steps how to find out by hand calculation. So this is a plane, Laplace plane, real, imaginary. Then you do the find out the roots of this. So these are the complex roots, and then you find out the asymptotes, and this will go along this way, this will go along this. So this is a root locus. But how would you do this in MATLAB? So let's do this. So you will go here in MATLAB, write down the command. TF means transfer function. So let me write the commands here. G is equal to TF. Numerator. So in the numerator you will write down like the coefficients. This is just 400, so I will write down the constant term. And the denominator, there are 3 coefficients starting from the higher order, higher degree, which is s squared. So the coefficient of s squared is 1, so I will write down 1 here. Coefficient of s is 12, I will write down 12 here. Coefficient of s0 is 400, I will write down 400 here. So once you do this, and then you will write down next command for the root locus. Root locus, in the parentheses, it will call in the transfer function and it will show you the same root locus. This is the one command which you should know. The other command is RL tool. This is also very useful command. What it does, it gives you option to draw the root locus, which is this one. Also draw the time response. Time response when the poles are located. Suppose step response for this one, it might have some oscillation and damp out. So if you want to see both the root locus and the step response, then you should use RL tool. So I'm going to show you both commands. So transfer function is numerator is, I believe, 400, denominator was 1, 12, 400, and then hit enter. This is the same transfer function. So let me maximize this, undock it. So now the next thing is root locus, or you see this is the same root locus which I just plotted here. So how would I know? There are a few steps which are important to draw this by hand. But if you compare, I didn't know what is the exact complex root location, but I know these are the complex roots. They are lying in the complex plane, and the root locus should look like this. And let me show you another command. Okay, the important thing in root locus, important thing is that it should never cross this imaginary axis line. If it crosses, then it means it is on the right half plane of the imaginary plane, then it is the unstable system. I will show you in a bit. So right now, do you see anywhere the poles are going, when we increase the gain value, the poles are going to the right half plane? No, they are not intersecting the imaginary line, and they are not going to the right half plane. It means the system is stable for any value of the gain. So let's do this. RL tool. I want to see what is the step response here. So what it does, it tells you a lot of things. So this is the step response. I want to show you the root locus. So let me see the video side by side, left and right. You see, now I want to change these. Right now the magenta color are the location of the poles. I can tweak these poles, bring it down. I can bring this down, hold this, bring it down, and see the response is the same. I can move it up to see the step response. It's become more oscillations. There are more oscillations. So I can increase the gain, the root locus. See, it becomes more oscillatory. Now, another thing I want to show you, if I add manually, if I add any pole in the right half plane, what will happen to the step? You will see, keep notice. I added one pole, it's unstable. You see 10 to the power negative, 10 to the power 26. So bring it down, it is still unstable. Still unstable. So I will erase this pole, and I will keep this original. So this is known as the root locus design of controller with the RL tool. By adding to, if you want to reduce, adding a 0 will increase the stability of the system. You see, system becomes more stable by adding 0. So let me show you. If I bring the 0 right at the origin, I would see what happens. So let me bring this over here. So as soon as I go just, if you see, if I go just to the right, it suddenly becomes unstable. This is okay. Your task is to do this root locus. Let me close this window.